we'd like to factor our rational function as much as possible. And it's going to take a little bit of work here because our numerator is not super obvious how to factor that. So we're going to do a little bit of work first to find the zeros of that numerator. Let's do our rational zeros function, theorem, rational zeros theorem, which says that the zeros of the numerator will be factors of the constant term divided by factors of the leading coefficient. So factors of 1 divided by factors of 2. So that gives us either a plus or minus 1 or 1/2. And briefly, without writing it down, Descartes' rule of signs tells us that we won't have any any positive zeros here because these are all positive. So there are no changes in sign here, so there are no positive zeros. So I'm only going to have to check the negatives here. Let's go ahead and test -1 real quick, okay, in our synthetic division. And we'll go through that pretty quickly because I think I'm probably pretty comfortable with that. And we see that -1 worked out pretty well. And so this tells us that that numerator factors as an x plus 1, and then those are the coefficients of what's left over. 2x squared. 2x squared plus 3x plus 1 all over the factored form of this, which is x plus 1 times x plus 2. And that right there factors a little bit more as well. That factors as a 2x plus 1 and another x plus 1. And that's divided by the x plus 1 over the x plus 2. So that's our completely factored form now. And now we're ready to cancel common factors. We have a common factor here of x plus 1, and so we can cancel that out. And we are left with just the 2x plus 1 times another x plus 1 over x plus 2. Now notice that because the denominator lost the factor of x plus 1, there are no more x plus 1s down there. That means we have a hole there when x is equal to -1. So we have a hole we plug a -1 in, and we're going to plug this into our reduced form to get the y-coordinate of the hole. And if we plug a -1 into this, we see that we actually have we have 0 in the numerator. And so it's 0 over 1, that's 0. So that's our hole. And now we can find some intercepts. Okay, x-intercepts. For x-intercepts, we find the zeros of our numerator. So if we take 2x plus 1 and set that equal to 0, solving for x, we get x equals -1/2. And that has a multiplicity of 1 because of the exponent on that factor. Okay, and then now we have to be careful because the x plus 1, we can't set that equal to 0 because we already know that we have a hole when that is equal to 0, right? When we plug -1 into that, we got 0. That was our hole. So it's not actually an x-intercept, even though it is it's a hole on the x-axis. Okay. Now we're ready for our y-intercept. To get our y-intercept, we just plug 0 into our function, f of 0. And I'm actually going to plug it in up here to our non-factored form, non-reduced. All the x terms just disappear, and we end up with 1 over 2. For vertical asymptotes, we get the zeros of the denominator, and we use the reduced fraction denominator. So setting x plus 2 equal to 0, we get x equals -2. And that has a multiplicity of 1 because the exponent on that factor is 1. Horizontal asymptotes we get if the numerator has a degree less than or equal to the degree of the denominator. That's not the case here, though. The numerator has a degree that's higher, and so we do not have a horizontal asymptote. For slant asymptotes, we need the degree of the numerator to be exactly 1 more than the degree of the denominator. In this case, it is. And so we know that we'll have a slant asymptote, and to find it, we will do long division. Now, We can do that long division with either this original one or with our reduced. I'm going to go ahead and do the reduced one. The numerator, if I multiply that out, we get 2x squared plus 3x plus 1. That was, of course, that thing that we already got it from. And then we're dividing that by x plus 2. So 2x squared divided by x is 2x. We multiply 2x by x plus 2, and we get 2x squared plus 4x. And we subtract that. The 2x squared cancels. We have 3x minus 4x, which is negative x. And then the plus 1 comes down. And then we do it again. Negative x divided by x is negative 1. And negative 1 times that divisor is a negative x minus 2. And we subtract. And we're left with just the negative x's cancel. We have 1 minus negative 2, which is 3. Now this has a degree less than the divisor, so we know we're done. And the slant asymptote is simply this, this quotient. So our slant asymptote is y equals 2x minus 1. All right, we've got a lot of stuff going on here. This is all the information that we need in order to graph this. I'm going to go ahead and kind of move things over a little bit just so that we can fit everything onto one screen here so that we can see it. Okay, so there's our information that we're going to be using. We've got our axes. And we start plotting the things that we know. We know we have an x-intercept at negative 1/2. We also know we have a hole at negative 1, 0. So that's right here. I'm just going to go ahead and, okay, that's my hole at negative 1, 0. The y-intercept is at 0, 1/2. So that's that point right there. We have a vertical asymptote here at negative 2. We don't have a horizontal asymptote, but we do have a slant asymptote. Okay, y equals 2x minus 1. That has a y-intercept of negative 1 and a slope of 2. So it's going to look something like this. Oops, let's make sure that we're not curving there. Gotta be careful with that. I need a little bit more space. All right. So now we're ready to start drawing. We have this point here at the y-intercept, and we need to, from this point, as we move to the right, we need to follow this slant asymptote. And the only way to do that is to be going up, of course. Okay. Now as we move to the left, we hit this point at negative 1/2. That has a multiplicity of 1, so we cross it like a line would. But then we have to come to this hole, and that hole at negative 1, 0, this is another important thing to note, that also kind of has a multiplicity, okay? The x minus 1 that canceled out, we just canceled out one of them. So that's kind of like the multiplicity of that hole. And so we cross through and follow our asymptote. Okay, and now I'm going to use a slightly different reasoning for this one than maybe what we've been doing in the past. Notice I cannot be going up right here and then come down and follow, because I would have to cross the axis to come down and follow the asymptote. So I can't be going up here. I must have a behavior that's going down. And then I have to turn around so I can follow that slant asymptote. So there's a sketch of this rational function. This probably shouldn't look like a point. It's a nice, smooth transition there.